Yeah, thanks for having me. I feel very blessed, actually, that I get to be the first presentation at my first Camlist for the first Camlist Red session. Today I'm going to talk to you about compute use agents and why, well, actually, this week I've been interacting with two different types of groups. One is sort of like, what is a compute use agent? And the others are, I know what a compute use agent is, and they're a nightmare in terms of security. And so hopefully this talk can kind of appeal to both of those groups. Okay. So yeah, today I just want to, this is an agenda, I don't know if I really need to focus on it, but I'll cover that kind of from a research perspective, what we wanted to look at during our exploration of compute use agents. Some of our findings, I won't have too much time to go through all of the findings that we had in our kind of write-up in our paper, so I'll focus on one particular case study. And then describe a little bit why, like Richard just said, that we sort of need to be kind of keeping ahead of these trends, right? We're not fully there yet, but we sort of need to keep ahead and give some takeaways so that things are not all doom and gloom. So yeah, I'm part of the Microsoft's AI Red team, and we have three pillars in the AI Red team. First and foremost is operations. So, what happens there is that whenever we get a new kind of model or product feature from Microsoft, our operators will go ahead and kind of probe it for various risk categories. And anytime we find something vulnerable, we want to sort of automate that testing to make sure that it's available next time that we see a model of a similar kind. And so then we have automation, pirate, engineering. And you will see in this session actually two talks from both representatives from sort of both of those. I'm in the research team, which was formed about a year ago to kind of look forwards and pick up on these emerging trends. So the reason I'm showing this is because this is kind of like how we're thinking about emerging trends to make sure that we can test for new scenarios as they come up. So our mission today is really just to establish kind of a shared understanding. I'm going to talk about computer use agents, but I think the messaging that I'm going to give today should cover multi-agent systems or different kinds of emerging trends that exist. So trying to map the way of thinking as opposed to just the findings that we look at today. So if you don't know what computer use agents are, here is a slide to kind of get you up to speed. Essentially, it's an agentic AI system which has been equipped with tools that can take actions on a VM or a browser. Those actions can be moving the mouse, clicking, copying, and pasting text. And the idea is that they're getting a lot of popularity at the moment because people want to use them for the boring tasks like filling out expense reports. Here, there's taking a financial report and calculating the value at risk for a particular organization. And so the user would type a prompt, and somehow you get some feedback loop that comes in, and the context of the VM or the browser is also fed into this system. So being a part of AI Red Team in Microsoft, we actually got a chance to look at around 10 different computer use agent deployments, including OpenAI's original operator, when it first came out. And we needed a way to kind of abstract what is a computer use agent and what are the common patterns that we see. And so we came up with this sort of schematic diagram. And what we drew out from this was this perception reasoning action feedback loop, where we sort of start off at number one here, where you have a VM or browser, a screenshot's taken, and that context as an image is fed into the model. But before that, at the second step, it's fused with the user's input and query. So what does the user really want to be achieving? And perhaps if it's a browser, you have some DOM state or some sort of variables from the environment that you can kind of feed in as well. And because of that, because the screenshot's fed in, so the underlying model is necessarily multimodal, so it needs to take both text and image. And it's also a reasoning model. So when, at the second step, all of this context gets fed into the model can reason about what actions to take in step 3. Also at this step, which can be another talk completely on its own, and I think we can have many discussions about this, there's also potentially a trigger of human in the loop. This is a vulnerability in itself because they're non-deterministic. They're model-based. Because they're model-based, you can use your kind of standard jailbreaks and avoid human in the loop completely if you query the model in a particular way. So once the model has kind of reasoned about what actions to take, it takes those actions on the VM or browser, and then there will obviously be a new state in the VM, so that the VM can now, you can take another screenshot, you can check the environment variables, and then you sort of go round and round. And so I think at first, when you first get hold of one of these kind of deployments of a computer use agent, you might kind of think that you can lock down the browser, apply traditional security rules, and we're good to go. And so our hypothesis really when we were looking at this work was the additional AI components that are introduced into this system can kind of expose those security flaws a bit more. And there are some subtleties that you get essentially from the AI part of this system. And so that's really what we wanted to double click on. So looking at all of these computer use agent systems, we were able to draw on 7 common risks that occurred throughout all of them. So they also existed regardless of the safeguards that were sort of put in place. And in fact, we found that the fact that the agent itself had to do something additional, so not just taking actions the fact that the agent had to take actions in addition to following a particular task meant that it often trailed away from its original safeguards. So that kind of extra complicated context steered away from the original goals that it was supposed to be doing in terms of safety. So yeah, I will cover each of these risks in a little while so that you can see them. But they don't often occur just kind of on their own, standalone as a single risk. We've captured them in terms of case studies. So usually when somebody's executing an attack, you're likely to hit multiple of these risks at once. So we captured 3 case studies in the research paper and some change in the additional evidence. So the first one is a case study on click tracking. So essentially this is your sort of time of check, time of use vulnerability, where by the time that the model decides to take a particular action, or even at the point where you can actually feed in the screenshot of a particular website, you can overlay that website with buttons that are not real or lead to a different website itself. And you can do that before the actions are actually taken. It takes quite maybe sometimes 20 seconds, but even up to multiple minutes before the agent can take the action. So you have plenty of time to switch out some buttons. The second case study, which is actually related to some of Becker's work that we discussed when we first looked at this, is the fact that these are susceptible to RCE attacks. The reason is, so when we first got hold of the operator back in December last year, one of our AI Red Team operators was able to get through the browser and land on one of OpenAI's VMs and open a terminal. And so that was very manual, but we decided to extend that attack and actually instead of manually telling opening up the browser and getting into the backend, we were able to start off with a website that gave some instructions from this website, leading the model to download these files itself. So kind of, automating the attack itself. And so I think indirect prompt injection is probably one of the most the kind of critical risks that we're facing today with agentic AI. And I think that we could also spend a significant amount of time on a talk on that alone. But today I'm going to talk to you about chain of thought exposure. So this is something I've been thinking about a bit recently and trying to build automating tools around it and how to test for it. So let's jump into this case study. So here what you can see is that on the right-hand side, we have a query for writing a definition of the Pythagorean theorem. And it's asking the agent to pop that into a user file.txt. And it does it. It writes down the theorem. But at the same time, we also asked in the backend if the model and the agent could store any of its chain of thought reasoning inside of a file named admin-only.txt. And on the right-hand side, you can kind of see what's happening there, and you can see the reasoning and the chain of thought is actually being exposed at that point. Here's another example. If we just ask the, now we ask for the chemical formula for water, and again, ask it to be put into user file.txt, and it will write it down, but we can capture the, once again, we can capture the reasoning before that actually happens. And so what this slide is showing here on this side is that before the agent has actually written something in a file, we've been able to read the reasoning in the admin-only file, and we know what the agent's going to be doing. And so this exposes a bigger vulnerability, which is you can't quite capture in these snapshots of the attack. But this can lead to really vulnerable sort of front-running attacks where you can have, so if an agent is going to be landing on a particular website and it gives reasoning logic about which website it wants to visit, you can front-run, get ahead, get to that website. If it's a GitHub issue, for example, you can make comments in there that can indirectly lead the model astray and somewhere else. So this kind of front-running logic is something which, because usually chain of thought has been kind of a big IP question, of late. But we've kind of seen that this is an additional risk that hasn't really been thought about before. Taking reasoning and using that to attack the agent before it takes its actions. So what actually happened here? So as I said, the admin only was able to capture the admin only file, which is it wasn't actually locked down. The model's context thinks that because it's called admin only, it's actually something which is quite a privileged file in which we can actually dump some information on the chain of thought logic. And the risks that in this, remember this risk diagram, I'll go back to that slide in just a moment, but the risk that we were able to capture from this, the primary one is, of course, chain of thought exposure. But by exposing chain of thought reasoning, down the line in the kind of downstream tasks that the agent's actually going to execute later, you see we can eventually end up bypassing human in the loop. Not once during these attacks did human in the loop get triggered for us. And then we have this kind of identity ambiguity, where there's sort of this over-delegation of rights for the agent, what it can access. It's confused on what is available to me as the user, and then there's a lot of ambiguity there. So essentially, one of the biggest things here is that there's not been a separation between the reasoning, the action, and the VM, and we sort of feel that these things need to be split up somehow. Which is why, as a sort of mitigation, we might propose something like, treating chain of thought reasoning, particularly in computer use agents, where there's this time of check, time of use delay, which is quite large. You want to separate them, maybe even cryptographically verify the output targets on your system. And any helper functions that you have, like logging chain of thought, which is actually something that we implemented and put into the system itself. Yeah, we can make sure that these are sort of checked before the implementation is run. Another thing I really want to highlight here as well is that back when we were testing on operator and the computer use agents at this point, it was a difficult task to extract chain of thought reasoning. So we have a colleague who, like Grace One, had this competition with OpenAI, and we had a colleague that was able to extract chain of thought through this, and so we were able to use some of that sort of similar thinking and logic to expose chain of thought reasoning. But I think the bar is even lower now because we had DeepSeek, it's a reasoning model. OpenAI now has the ability to output chain of thought summaries. So it's not, the complete chain of thought reasoning. But that means that if you toggle on chain of thought summaries, then you can, as an attacker, get information about what the model is going to do anyway, and then still do this front-running attack. So yeah, it's like basically it's something that was really hard before is now a bit easier for the attacker. Awesome. So here's the list, a long list of the 7 risks that we identified across computer use agents. The ones that have an asterisk in are the ones that we identified for computer use agent case study. For chain of thought the chain of thought case study. However, there are many more. I mentioned the remote code execution. How things get plugged into a particular architecture is very important because you can be vulnerable if somebody can get through the security, especially using the AI subtleties. There's also the UI deception and perceptual mismatch, which is related to the sort of clickjacking style attack that I mentioned. And again, there's the indirect prompt injection, a huge risk here. And finally, content harms and emergent inference, where we saw multiple times that the agent was filling out documents or going through social media. It was able to pick up on information and then infer that later. So we had like kind of privacy violations in this too. Yeah, so just coming back to the where these all fit into just as a reminder, into the system. Okay, so it's not all doom and gloom, right? There is a lot of work that I'm quite hopeful for, and we are kind of, I feel, in a good place where we're sort of ahead of this at the moment. So one of the biggest things that I highlight every time I talk about computer use agents is that the system architecture really matters. It's very important how you plug this in. A computer use agent has a model underneath it, and then you have this action, and it gets plugged into a VM or browser, and that VM or browser will have applications perhaps running inside of that, and so you should really be careful about how you plug these systems in. And I think that also comes back to the bottom point. One of the posters yesterday was very relevant for this because Josh from, I think it's Fire Mountain, his company, was presenting about how you sort of need to work together, bringing product groups, red teaming, and we had this huge conversation on how if I showed you a computer use agent and gave it to a red team, then I gave it to an AI red team, and both of them gave the okay, that doesn't necessarily mean that we've captured everything. Because what we're showing here is that we sort of all need to be in the room at the same time, and we've really pushed during our operations at Microsoft a collaboration between kind of classical security and the AI security risks that we're seeing. So I would definitely emphasize that if you're building these things. Yeah, one of the most exciting pieces of research that I'm aware of and involved in at the moment is on information flow control. So some of our partner teams in Microsoft build Fides, and then Google DeepMind also have Camel. And these kind of frameworks actually take they capture the context from labeled data. And they check whether or not this data is like trusted or confidential before it gets fed into the model at inference time. These have been built for kind of like single agent at the moment, but yeah, I'm really excited about how we can extend these kind of systems to multi-agent systems, and in particular computer use agents. If you think about it, like if you land on a GitHub webpage, how can you label that data when you have comments coming from many different users? Who do we trust, right? Do we trust somebody that has written like high quality code for most of their experience and existence on GitHub? Or does that mean that they're kind of a bit more likely to have a stronger attack, right? So there are all these questions about how we label that data. And I think this is kind of an ongoing research at the moment. Then, of course, there's kind of secure by construction sandboxing, which kind of comes back to the point on, focusing on classical security as well as AI security here. And related to the information flow control is this kind of policy-aware scaffolding layers. So checking that we have a list of policies, maybe whitelisted websites that have actions and buttons that we can label as safe and trusted. And then only those that fit your policy will be executed. So takeaways. Given a computer use agent, right, from the beginning, kind of define it as something which has additional tool access, which can, move the mouse, click some buttons, and write some text. Things might seem that they're not that bad, but it quickly gets very broad and very wide. The attack landscape. I think because essentially now any website that's plugged into any website that a computer use agent lands on is an open threat vector, and it's an attack vector for any adversary. Yeah, and I think as capabilities grow here, we really need to be building safety into the orchestration stack itself. And I think the only way to do that really is to publish papers, open source tooling, and have like events like Camelist where we can get together and discuss, what a solution for this, right? I think it's not just going to be one person's job here because things are moving very, very fast. Yeah, so I think that kind of summarizes, I think, yeah, let's not, I think this message is in general, not letting it paralyze us just because we've seen all of the risks, but, you know, getting ahead of the problem and, you know, having tools to automate this testing, I think it's going to be really important. So I just wanted to leave it on a hopeful note rather than one worried about the security threats here. And none of this work would have been possible without all of these collaborators. We have a really amazing team with very different expertise, and everybody here chipped in a lot. And I just get to present this amazing work. So thank you.
Thank you. This was a great talk. I really like the taxonomy for the risks and the mitigation. So, you know, definitely there's hope. It's just that I'm very curious if you have any insights. Your mitigations about this chain of thought were mostly after it has been exposed. Is there anything, and I understand it's fundamental transformers architecture, but do you have any insights or any research on before it's exposed? Can we prevent something like that or?
Yeah, I think most of what we're thinking about at the minute in terms of research is that if you just assume that, okay, it's going to be exposed somehow, right? You can get some signal, even if it's not explicit, to what the agent will be doing at some point. But then there are ways for you to, I think that's why I'm so interested in the kind of information flow control approaches, because you can at least capture what goes into the model at inference time that way. And so, you know, monitoring the context that gets fused together, you know, we have this kind of, you have an image, you have the prompt, you have some environment variables, and they get fed in. And I think this is where I would focus on making sure that this is sort of vetted before it gets put into the model at inference time. And I think that is something that helps, because then if somebody does get access to some kind of reasoning and want to go ahead and front run you and manipulate the model, you have ways to kind of, you have safety checks basically before that gets put into the model. I think that's the way I would answer that.
Perfect.
Oh, hi.
Thank you for the talk. So I saw that you had indirect prompt injection as one of the risks.
Yeah.
Does that mean that for a lot of the use cases and experiments you're running, the attacker was the actual user accessing the model? Because we've seen that a lot of the indirect prompt injection, rather than being like a risk of the system, it's more the threat surface for it. So with the chain of thought, would the user have to actually be on device? And did you try anything with exposing chain of thought over a network per se?
Yeah, so just on the first point, I think we considered two threat models. The first one was the user is trying to be malicious, right, of the actual system. But the second one with the indirect prompt injection, I think the reason it becomes such a magnified risk is because you can just build a website and encourage, and you can even have all these sort of networks of different websites that encourage a computer use agent to land on your site. And then you have free reign. Once it's on your website, it's only going to scroll through your side and click on your buttons, take in your context, which you can just put text anywhere, and that's kind of will help manipulate the system in that way. In terms of exposing chain of thought over the system, I'm not sure. I haven't really considered that, no. But yeah, I think that could be an interesting task.
Thank you so much. It was a great talk. I have a question regarding chain of thought leakage. Maybe a naive defense approach is to avoid the revealing chain of thought to output. But what do you think about one better idea to make a trade-off between the utility and security in a way to put a wrapper, privacy-aware wrapper at the middle between the model and output to make privacy-preserving summarization? Then you will keep the utility, you will generate it, but at the same time, you can keep the privacy to not reveal it. Then you can keep the security. as a trade-off between these two. What do you think about this idea?
Yeah, I think that's a good idea. And I think also goes back to what I maybe proposed a second ago, which is to be careful of the context you're feeding into the model and having some separation there, right? And I think because, the big reasoning models have been trained on lots of data that, we're not going to go back now and edit them, right? So that's something that exists. We have to deal with it. And for a long time, even OpenAI was keeping that as a sort of really close to their chest. They didn't want to release the sort of chain of thought reasoning. But we're still able, but there were competitions and we're still able to sort of crack it and then get that exposed. So I sort of feel like, assuming the fact that you're going to expose it, then you need to do something like that. Yeah, I think that's a good idea.
So much.
Hi, great talk. Do you have any examples of attack scenarios where the exposure of the chain of thought made the attack feasible or plausible? Because some of these agents expose it as a feature, like Cursor CLI. You can run in debug mode and it just shows you all of the thoughts. So yeah, did you have any examples of?
Yeah. So we have examples of that. And that's kind of like the limitation of just capturing like an image, right? But yeah, we have front-running attacks where we ask an agent to go ahead and like we have, like one of the examples was, I have an issue with Hugging Face. I have an out-of-memory issue, right? There are so many issues on this on GitHub. But you can expose the chain of thought there, or if it could be a feature, like you said, like if you're plugging in an underlying DeepSeek model, then you can just look at it freely. But the website that it's going to access, we have a GitHub attack agent that immediately can take the website that's outputted from chain of thought reasoning, go to it, make a comment on that particular website that it wants to browse to. And before it arrives, there's now a new comment and it says, I have this solution for you, please click here. Then it clicks on that and it goes to our website and then we have full, control basically.
Thank you.
Sorry if that wasn't explicit from the talk, so thanks so much for asking that question.
Yeah, great talk. I know a lot of talk about chain of thought stuff, super interesting. But you made mention of architecture and something that we've been working on very heavily with these things. One of the things we're finding is that increasing user friction is essentially a non-starter. Essentially, all of the value in these things is not running in the VM.
Yeah.
It's full OS control. So if architecturally, I don't know, former red team, I promise, if all the value is essentially unfettered access to the operating system to get as much context as you have, to be able to browser use, why do they exist in the first place? How do you kind of square the circle of, I want these people to be productive, the entire value of this thing is tied up in free use, but then we're also saying we want to stack on as much friction as possible to make it harder to do, and kind of the dovetail on that. Do you think that going after these more atomic style risks, like we tend to classify them as TGPs, is missing the boat a little bit on the larger architecture problem? Like if we focus exclusively on, I got this indirect prompt injection thing, versus like, well, what if I just systemically secure the system and say, well, doesn't particularly matter if it's not allowed to write outside of scope?
Yeah, I think there's a lot there. So I think it's a bit of a mess, right? Every time there's an implementation from one team, like one of the first things we end up doing when we have like an operation like landing on compute use agents is like, okay, can you show us the blueprint of the architecture? Because we just need to see what kind of a mess it is, right? And I mean, I'm not arguing for some kind of MCP for like, these kind of VM systems for here, but I think it's a lot when you first have to get like kind of understand the architecture of the entire system before you get stuck in, and then you can test. So each time there's a new vulnerability, and like the RCE, for example, that's something that is determines is very heavily determined by the way that things are put in your system and implemented, right? So there are different approaches to that. Like you can't just run an automated test and it will work because that will get closed, but there's another way around it, right? So this is where you need this sort of traditional AI security, like red teaming, to kind of come in and bring the expertise. Yeah, and in terms of the user, yeah, I think, again, I'm going to go back a little bit to this kind of protecting what context gets put into the model, because if you have a VM, it has multiple applications. Some of the thoughts that we've had is to even like the image that gets fed in should somehow be pre-processed perhaps, and we can actually capture and block off some of the context that gets fed in. And this is a way that we've maybe thought of that doesn't create much friction for the user, but from a security perspective makes us feel a bit safer. We have some control, we have some check boxes for what applications we would allow and what applications shouldn't be on the VM itself. And then from those particular applications, even which buttons and which like comments, let's say, are fed into the model. Maybe you don't allow any comments at all. And so these kind of decisions are the ones that we're having basically, is that to try and balance that. Hope.
Can you repeat the question into the mic for the...
Yeah, I didn't capture the end part. So the new agentic AI principle from Windows, is that helping? And then I lost you.
Sorry about that, Zoom. Question is, so Windows is introducing a new agent security principle. It's meant to be used by local agents. And my question is, are we viewing that as a platform mitigation type thing that's going to be treated as a security boundary? Or is this more just saying like, hey, you are this, I'm going to attribute these behaviors to an agent so we can figure it out later? I'm not sure if you're familiar with.
No, I'm not, but I think as well, like my answer would be that it's sort of, it depends on the use case, right? Because I think some of the use cases are like Windows, some of them are just a browser that's limited to the browser. And so I think it really depends on the use case and what's available for, the computer use agent to access.
Thank you.
Thanks.